solution is done in your school. I think
Yes,
electrochemistry is also done,
solution
right?
is done, electrochemistry is done. Now we are doing haloalkanes.
Not chemical kinetics, haloalkanes.
No, yes, haloalkanes.
Okay. So did you ask your teacher, sir, why did we jump to haloalkanes? हाँ इनाया, आपने पूछा नहीं पूछा?
No.
No, why? You should ask now. You should ask the teacher, say why haloalkanes, sir? Make a very like sweet face and then ask. Okay, and then you rudely don't ask rudely. Ask them with a sweet face, sir. Why haloalkanes, sir? Chaliye. So they will say, I have been teaching for this many years and so on. So, fair. Solution electrochemistry and haloalkanes. And when is your test? I think I have got something from Mariam.
Probably the test is from June 6th.
June 6th.
Yes.
June 6th. I think these 3 chapters will be there, or you will be having more chapters.
No, we'll be having only 2 chapters, any of the 2 chapters. Most probably the solutions in electrochemistry.
Solutions in electrochemistry. And you will be having a half yearly on in June itself?
No, that will be in October.
In October, okay.
Yes.
So tell me, how was your 11th standard? Chemistry.
It was good, alhamdulillah.
It was good, alhamdulillah? Okay, fine. That's good. So, like, where do you see most of your problems in chemistry? Like, I will divide it into physical, inorganic, and organic. So, you have more difficulty in numericals, you have more difficulty in memorizing things, or you have more difficulty in organic reactions?
I have difficulty in the numericals part. Memorization is good for me.
Memorization is fine. Just by the way, what's your stream? PCB, PCM?
PCMB.
Oh, अल्लाह समझ रहे आपके लिए नहीं हम सबको बोलेंगे कि आपके लिए दुआ करें, है ना?
जी
पीसीएमबी वाले बच्चों के लिए खुसूसी दुआ करवाते हैं हम इज्तिमाई तौर पे कि पीसीएमबी वाले बच्चों पे अल्लाह ताला रहम करे. Why PCMB?
Actually, I want to study over here in Saudi. So for that, I have to write the SAT exam, which requires math. But then my interest is in biology.
Okay, fine.
Yeah.
So you want to study medicine in Saudi itself?
Yes.
Okay, fine. So how is it like? I know there are some colleges. I think there is one student who is in Jeddah. She's doing medicine. And how is it though? Is it good?
Sorry?
In Saudi, is it good? Or is it like okay? Any idea?
We're still researching about it, so not really sure. Yeah.
So I think
I
you
don't
will be
want to go to
also
India anyways, that's why.
want to go to India. But no matter how many years you stay in Saudi, I mean, very rarely they give citizenships. No, very rarely they give, right?
Yes, very
But
rarely.
but the chain can continue. Like your father, I don't know.
Yeah,
Maybe
my
your father
siblings
came.
and all.
Uh, your father came. Then you are there. You get a job there. Then the next generation get a job. Then the next generation get a job. I think
Yes,
if
yes.
that continues, then it will be fine. So you have been brought up and born and brought up in Dammam?
No, I was born in India, and then I was 2 years, 3 years in UAE, and then I came here. 12 years
So
here.
when you buy things, do you convert in rupees and then buy, or you just directly buy in riyals?
No, directly buy in reals.
So you're nowhere near any Indian, I guess. Then ठीक है तो. This is a difference that I
Some
generally see. Some people do. They convert to Indian rupees.
only for big amounts. Like if something really big we're buying, and then we think about it, oh, it's this costly in India.
That
Like
you
that.
have no, but what you like? For example, if you want to buy a phone or something, and you are asking your father, then do you convert it or like just
Yeah,
directly?
I do convert it.
Some
Yes.
Indian is left hand side. Okay. So tell me, we will deal with numericals here. Okay. So there are mainly
Yes.
three problems that students face in numericals. The first one is that something is missing in the question. Like there should be some more information given. Do you
Actually,
face
I'm
this?
weak in my math part.
If you're okay, you're weak in math, but you are able to understand which formula to use and everything, but you do some silly mistakes.
Yes, the silly mistakes are there.
Okay. So for silly
Mm.
mistakes, there is only one thing that you can do. First thing is that no backside calculations.
Mm.
Like, where do you calculate? Like on the same page where you are doing the problem, or you turn the complete copy backside and then you do the
No,
multiplication division
I
on the
do it on the
backside
same page.
on the same. Okay. So then maybe the
Yes.
next thing will help you. No backside calculation. Another thing is you have to write in the same size. For example, if I am doing, let us suppose we are calculating molarity. So I've written number of moles is 0.213 and the volume of the solution is, let us suppose, 0.5. So
Yes.
when we are going to divide this number, okay, so first of all, you will to convert this into 213 divided by 500, right? We can do
Yes.
this, makes sense. Or other
Yes.
way you can do is maybe this will be better. Division छोड़ देते हैं अगर हम 0.5 can be written as 1 by 2, correct?
Yes.
And denominator of denominator is the numerator, right?
Mm.
So it will be 0.213 multiplied by 2. When you multiply it, you do it like this, 0.13 into 2. You write it in a very small size, or you write it like this.
No small size.
This, you have to change this, okay?
Yes.
Okay, so that is one thing that you will do. Same size, you have to write in same size. If you don't do any backside calculation, then the next thing that you will start doing is writing it in the same size as you are doing the fair. The rough and fair should be same because nothing is rough now. If you do any mistakes in the rough part, that will be copied to the fair part. So rough part
Yes.
is as important as fair part. That is why we will give that much respect to the rough part, whatever respect we give to the fair part also. Okay, so same size of calculations. Huh? Same. Yeah, I don't know how to write it in a proper way, but same size. Third thing is that first of all you will uh, calculate or solve. I should say simplify. I should say simplify powers of 10. Okay, so if you have powers of 10, then you will simplify that first. Then you will move on
Yes.
to, after that, you will move on to the numbers. Then you will simplify the numbers. Now, another thing that you are going to do is you don't need to divide each and everything. Okay, so the division or answers in decimal should come only at the end. Okay, you should not be dividing
Yes.
like each and everything. Okay, so you should be uh, don't simplify to decimals until the last step. Okay, so everything should be in fractions until the last step. Fractions are going to help you a lot. Keep things in fractions always. At the end, you are going to simplify it till the decimals. Okay. So, school, can you please
Yes.
write this down?
Okay.
Done, Inaay?
Yes.
So, now tell me a topic that you have problem in, or else I will choose a topic for the trial and explanations. Any topic that you have specifically doubt in or you did not understand correctly.
Nothing like that really.
Nothing like that. So let me start with some topics and then maybe you can identify. Henry's law, concentration terms, I hope that will be fine with you. And
Yes.
you just need to do a bit of more problems. So let me just start with concentration terms and I will give you one problem. Okay.
Yes.
Calculate the molality of 10 percentage. This is percent, not 7. Okay. Right.
Yes.
10 percentage W by W aqueous NaOH. So, okay. I will give you the molar weight of NaOH. Molar mass of the solutes are generally given in the board examination. In NCERT, it is not given. I don't know about schools. Some of the schools they give the molar weight, but in boards you will always get the molar weight. Yeah? So molar weight of NaOH is going to be 40. Try to do this. If you are able to do, if you're not able to do, just let me know.
Yes.
Yes. Inaya, any progress?
I'm finding the number of moles.
Again, you will take care of those things. You know, no decimal till the last step, everything. Okay. Okay. Number of moles, you will not calculate the number of moles in decimals. You will keep that in fractions. Okay.
Yes.
And the last step, you will convert everything to decimals.
This 10% of NaOH will be 10 grams of NaOH in 100 grams of water.
Yeah, that is correct. That is the correct translation for this particular phrase. That is 10 gram of NaOH in 100 gram of
Water.
what? Solution, not water.
Solution.
Now there is a difference now, because when we
Yes.
write 10 gram of NaOH in dash grams of water, what will be the amount of water?
90 grams of water.
Correct. Okay, so from here you will get the number of moles of solute, and from here you will get the mass of solvent in kgs. Right? A is for solvent, B is for solute. Okay.
Yes.
And then once you get both of these things, you will divide them to get the molality. The formula for molality is M. It is equal to number of moles of solute divided by mass of solvent in T. Okay, please do this. Yeah, did you get the answer?
$2.8.
Number of moles will be equal to 10 upon 40. So we'll keep it as 1 by 4. The mass of solvent in kg will be equal to 90 grams. So I will divide this by 1000 in order to get kgs, right? So I have
Yes.
molality will be equal to number of moles, that is equal to 1 by 4 divided by 90 upon 1000. So denominator of denominator will go above, and we will get molality. It is equal to 1000 in the numerator. The denominator will be remaining with 4 multiplied by 90. Correct?
Yes.
So 4 and 100, this can be divided by 25. 24, 25. Enough.
Yes.
Yeah, so this will be 2.8 and 2.8 is fine because 9 threes are 27 and 25 is just bit less than 9. Sorry, just bit less than 27, so it will be 22.8 moles per kg. So these type of problems are not having difficulty. You're having difficulty in more complex problems where you have 2 or more formulas involved, I guess. Okay, so for that, you will need to practice in the classes, but I will give you one question that will maybe help you. Okay. So you have done solution in your school, right?
Yes.
And you remember the formula for osmotic pressure?
I haven't learned that part yet.
Don't remember the formula also?
No.
No, fine. Not. Right. Otherwise, it's a very good question on osmotic pressure that will have helped. Okay, so what I will do now, I will just provide for you the 3 main solutions that we can have. So in solution chapter, we are going to deal with solute and solvent. And the solvent is always going to be liquid. No, that we are going to specifically study in this particular chapter. Otherwise, we can have, if you look at the table that is provided in the solution chapter in NCERT, then you will see that you can have gas as solvent, we can have liquid as solvent, we can have even solid as solvent.
Solvent.
Okay, but what we are going to study in detail in this class is the solution in which liquid is the solvent. And when liquid is the solvent, there are 3 types of solution that we can make. We can make a solution in which solvent is liquid and we have added gas. So that will be gas plus liquid, gas plus liquid. We can have liquid plus liquid. So I will write liquid A plus liquid B. Liquid A is the solvent, liquid B is the solute. And we can have solid, that is my solute, and liquid. Okay. Now, another thing that we are always going to study is about the vapor pressure. So when we have solution and the tendency of the solvent molecule to escape out, whatever is volatile, not only solvent, if there is anything that can escape out the solution, then that they will be having their vapors just above the solution. And these vapors, since they are gases, they will apply pressure, and that pressure it is known as vapor pressure. That pressure is known as vapor pressure. Now, when we are in gas plus liquid, we know that the escaping tendency of gas will be greater than that of liquid. Does that make sense? Escaping tendency of gas, because gas particles, they will be having a larger speed. Escaping tendency of gas is good. So I can say that the pressure, it will be directly proportional to the amount of gas we have added, and the amount of gas is represented by the mole fraction in this. The pressure will be directly proportional to mole fraction of the gas. Okay? And for this, what we can say, if I remove the proportionality sign, there will be a constant that is KH, because Henry gave this particular law. That way it is KH into pi. So I understood why we have taken only the solute in this case, because it is gas. Make sense?
Yes.
Now we will also talk about this KH particularly. So if I talk about if I keep the mole fraction same, and if I change the KH, what is the change on pressure? We are going to talk about that. So mole fraction is not changing. If I increase the KH, the pressure will also increase, correct?
Yes.
Now the pressure would only increase if there are more vapors, correct?
Yes.
There will be more vapors only and only if more gas is escaping. More gas escapes, correct? Now, when the KH increases, more gas is escaping. That means we can say when the KH increases, gas does not want to be in the solution, and hence, if I talk about solubility of a gas,
it decreases.
It will be inversely proportional to KH. KH increases, solubility decreases. Makes sense now?
Yes.
Next is liquid A plus liquid. So obviously we will be talking about the vapor pressure here. So that vapor pressure, the P total, because liquid A is also volatile, it can evaporate. Liquid B will also volatile, it will evaporate. Liquid A will put a pressure, PA. Liquid B will put a pressure, PB. And the PA, the amount of pressure, just be here. Don't worry. Maybe you see that this formula is not fine. The amount of pressure that is by A will be directly proportional to the amount of A we have added in the solution. Make sense?
Yes.
Similarly, the amount of pressure due to B will be directly proportional to the amount of B we have added in the solution. Correct? Now, PA will be equal to some constant. I will write A into chi. K is any constant. Okay. We will try to understand what is K also. Till here, everything is fine, Inaay?
Yes.
Wait a second. No, not everything is fine. Chi A will be
A is wrong here.
A is. So now you'll understand what is this K. In order to understand K, what I will say, let us suppose the chi A, it is equal to 1. What is the value of chi A? The mole fraction of A is 1. That means we have only A in the solution, correct?
Yes.
Because it is 1. Now we can say this K is the pressure. This K is the pressure when we have only A. Make sense?
Yes.
That means we can say that K is what it is, the pressure when we have only A. That means the pressure of pure. So I will substitute this and I will get PA, it is equal to P naught A, chi A. Similarly, PB, we will get it as P naught B, XB. And the P total, we can plug these values in the PA and PB, we will get P naught A, chi A, plus P naught B, chi B. This makes sense, yes or no, Inaay?
Yes.
Next is solid plus liquid. So obviously solid will not be evaporated. Liquid will be evaporating. This is our solute, right? P. It's our solute. And liquid is what it is, our solid. That means in this particular case, the total pressure of the solution will be directly proportional to the mole fraction of only A, the solvent. So we can then write, and from the previous case, we can say that the P total, it will be equal to P naught A chi A. Makes sense?
Yes.
Yeah. So now what we will do, we will rearrange this and we will write chi AS. This is P total. It is equal to P naught A. And chi A can be written as 1 minus chi B. Correct?
Yes.
The only reason of changing chi A to chi B is because is that we always talk about the concentration of solute in general terms also. अगर आप चाय के बारे में बात करते हैं ना, then we say पत्ती ज्यादा है, चीनी
Hmm.
कम है ना?
Yes.
Those terms. So that's why we'll always talk in terms of solute. And when we rearrange this, I will get P total is equal to P naught A multiplied by 1 will be P naught A minus P naught A multiplied by chi B will be chi. Next, what we are going to do, we are going to get this minus P naught A that side and P total that side. Okay, so ऐसा करते देखिए. P naught A into chi B minus P chi B plus is equal to P naught A minus P total. ठीक है?
Hmm.
Fine in
Yes.
it. The P naught A, it represents the vapor pressure of pure A. P total represents the vapor pressure of the solution. So this particular value, it tells about the lowering of vapor pressure, LV, lowering of vapor pressure, because P naught A जब सिर्फ क्या था, सॉल्वेंट था, सिर्फ पानी, आपने जैसे ही डाला कुछ सोल्यूट तो P टोटल हो गया, तो कुछ कम हुआ होगा, because
Hmm.
there will be some solid particles on the surface, and since
Hmm.
solid particles are on the surface, the solvent molecules will not be there and they will not be escaping out as they used to escape out when they were in the pure. That is lowering of vapor pressure.
No.
And
Yes.
when I divide this P naught A minus P total divide by the initial pressure, that is of pure A, that is P naught A, what I get is known as relative lowering of vapor pressure. Okay? Now
Yes.
this lowering we have this lowering, what we have done, we have related it to the initial pressure. The initial matlab kya? Jab we had pure solvent. That is why it is relative. Okay? So this is relative lowering of vapor pressure. You understood all of these three things?
Yes, sir.
ठीक है. And since you said ना you have not done osmotic pressure, ठीक है, थोड़ा
Yes.
osmotic pressure आपको समझाते हैं, fine?
Yes.
अभी लिखने की जरूरत नहीं, ठीक है, सब समझने की जरूरत है. The main thing is that the way I'm teaching or the way I'm trying to explain things that should be okay with you, ठीक है? So osmotic pressure से पहले we will try to understand what is osmosis. I think you may have some idea about osmosis. Do you have any idea osmosis?
The the transport of water from higher concentration, no, from lower concentration, no, from higher concentration to lower concentration.
ज्यादा पानी से कम पानी, ठीक है ना यार?
Yes. Yes.
ठीक है, असल में वो दिक्कत है जो आपने जहां आप कंफ्यूज हो रहे हैं ना, दैट इज अ पॉइंट जहां पे होना चाहिए कंफ्यूज. Because biology में जब पढ़ाया जाता है, they say that higher concentration to lower concentration. The reason is that when in biology we say higher concentration to lower concentration, we are talking about higher concentration of water to lower
Yes.
concentration of water. ठीक है.
Hmm.
अब देखिए केमिस्ट्री में पढ़िएगा तो आपको दिखा रहेगा lower concentration to higher concentration.
Hmm.
Because in chemistry, whenever we talk about concentration, we are talking about solute.
Oh, yes.
है ना? अब
Yes.
समझ में आ गया, है ना? तो
Yes.
बेसिकली क्या है, ज्यादा सॉल्वेंट से कम सॉल्वेंट, ठीक है, जहां ज्यादा
Yes.
सॉल्वेंट है वहां से निकलेगा ज्यादा पानी से कम पानी. ठीक है. अच्छा ये होता क्यों नहीं, उसको समझते हैं. ये तो आपको पता है ऑस्मोसिस क्या होता है, लेकिन होता क्यों नहीं. लेट अस सपोज वी हैव, इस तरह से हमने ये बीच में एक सेमी परमेबल मेम्ब्रेन भी रहना चाहिए बाय द वर्च्यू ऑफ द डेफिनेशंस एंड एवरीथिंग, बट उस पे बहुत ज्यादा फोकस नहीं, इतना तो याद रखेंगे ना, सेमी परमेबल मेम्ब्रेन वगैरह. तो ये पता है ना आपको दैट देयर शुड बी अ सेमी
Yes, sir.
परमेबल मेम्ब्रेन.
Membrane.
सेमी परमेबल मेम्ब्रेन का मतलब ये ना, ये क्या करता है, इट विल ओनली अलाउ द solvent molecules to travel between these two compartments. Right? It will not
Yes.
let these solute particles. So here I am taking pure water, and here I have taken, let us suppose 1 molar of, let us suppose what, NaCl. ठीक है. अब ध्यान से सुनिए जरा. In pure water
Just
we
1
have
minute,
what?
sir. So, from the you said that osmosis from lower concentration to higher concentration, lower concentration of water or solute?
लिखा तो है हमने of solute.
Solute, right? Because
lower
in the
concentration.
notebook, our teacher gave the definition, uh, the flow of solvent molecules from less concentrated to high concentration through a semi-permeable membrane.
Can you repeat that? From
Flow of solvent molecules from less concentrated to higher concentrated through a semi-permeable membrane.
सही तो है, सेम चीज हमने भी लिखा है.
This concentration is in terms of the solute or the solvent?
मतलब आपके टीचर ने जो लिखा है,
Because over here she only gave us less concentrated. Didn't say about the solute या solvent का.
कौन से टीचर ने लिखा है, बायोलॉजी या फिर केमिस्ट्री? केमिस्ट्री टीचर ने
No,
लिखा है ना,
chemistry.
तो वो सॉल्यूट के बारे में बात कर रहे हैं. ठीक है.
Okay. Yes.
अब ये समझते हैं ना होता क्या, मतलब वो तो बात की बात है. ठीक है, ऑस्मोसिस का डेफिनेशन वो बाद में यहाँ से समझ में आ जाएगा बिल्कुल आपको कि क्यों हो रहा है, क्या हो रहा है. यू विल ऑल्सो एग्जैक्टली अंडरस्टैंड कि कहाँ से कहाँ फ्लो होना चाहिए. ठीक है. तो इन
Yes.
प्योर वाटर इन द सर्फेस विल बी ओनली हैविंग वाटर मॉलिक्यूल्स. करेक्ट है.
Yes.
एंड when we have solution of NaCl, then we will be having some water molecules और बीच बीच में हम NaCl बाद में डाल देंगे. अभी ब्लू है मेरे पास, NaCl थोड़ा सा गंदा है ना, तो ये लाल हो चुका है, वाइट इज रेड. ठीक है.
Yes.
So obviously we will be having more vapor here, more vapor pressure here, because water can evaporate, right? So if water
Yes.
evaporates, so it will be having more vapors. This side there will be less vapors here. Okay, because the surface is also occupied by NaCl molecules, and NaCl molecules, they are not going to evaporate. So the number of molecules of water on the surface in A compartment is more than in B compartment. Correct है ना यहाँ तक?
Yes.
ठीक है. So if we have more vapors, that means the vapor pressure will also be more. More vapors. Here we will have less vapor. Please understand, when we are having more vapors, more vapor pressure, then what is happening? These molecules are actually applying a pressure on this compartment. So there is more pressure here. So there is a pressure that is applied on this compartment. And when you apply pressure on this compartment, then what is going to happen? एक प्रेशर बन रहा है ना, तो प्रेशर बनेगा तो यहाँ से यहाँ कुछ फ्लो करेगा. And because of semi-permeable membrane, what is going to flow? Only the solvent molecules are going to flow. So pure say NaCl. तो pure water तो क्या है? Less concentration.
Less concentrated.
And NaCl will be more concentrated. क्या ख्याल है?
Yes.
ठीक है. अच्छा, ये तो हो गया मतलब ऑस्मोसिस के बारे में. अभी तक पढ़ रहे हैं हम लोग. ऑस्मोटिक प्रेशर क्या होता है सुनते रहिएगा. ठीक है, बस आराम से, मतलब ऐसे मूवी चल रही सुनते रहिएगा. व्हाट इज ऑस्मोटिक प्रेशर? ए कंपार्टमेंट में प्रेशर ज्यादा है ना, तब ऑस्मोसिस हो रहा है. करेक्ट है ना?
Yes.
Let us do something. What we are going to do, we are going to apply external pressure on the B compartment. कैसे भी करते हैं, ठीक है ना? What we will do, we will apply P external
pressure
on B compartment. कौन से compartment? More concentration, higher concentration. ठीक है?
Yes.
Now, if we apply pressure equal to the pressure on the A compartment, then osmosis will stop.
No, we'll have to apply excess pressure.
नहीं, इक्वल कर देंगे तो तभी तो रुक जाएगा. नहीं, तब यहाँ पे दो बार प्रेशर है, यहाँ पे भी दो बार प्रेशर कर देना तो रुक जाएगा ना ऑस्मोसिस, कहीं नहीं जाए, है ना?
Yes. Yes.
ठीक है. तो दैट द प्रेशर, the external pressure which we should apply in order to stop osmosis, वही osmotic pressure. Make sense?
Okay. Yes.
What is osmotic pressure? Osmotic pressure applied on higher concentration site to stop osmosis. ठीक है. Make sense tonight here? एक बार देख लीजिए, आराम से देखिए. No need to write. Make sense ना आपका?
Yes. Yes.
ठीक. अच्छा, एक काम करते हैं, अब हम कंपेयर करते हैं ना. 1 molar NaCl है, and we have 2 molar NaCl. Okay. So 1 molar NaCl में अगर let us suppose we are in 1 molar NaCl, the pressure that we have to apply, or rather pressure apply नहीं कर रहे, इसमें actual pressure जो है without any external pressure we are having, let us suppose 0.5 bar. ठीक है. जब प्योर वाटर था तो 2 बार, 1 मोलर में इट इज 0.5 बार। अच्छा, जब 2 मोलर कर देंगे कंसंट्रेशन को, देन व्हाट डू यू थिंक, इट विल बी मोर देन 0.5 या लेस देन 0.5?
Less than 0.5.
इफ आई हैव 2 मोलर तो और भी सॉल्यूट पार्टिकल्स यहाँ पे आ जाएंगे ना, करेक्ट है?
Yes.
तो वेपर कम हो जाएगा या ज्यादा होगा?
Come.
कम होगा। दैट इज वाई वेपर प्रेशर विल आल्सो बी लेसर। सही है।
Yes.
यहाँ पे मान लेते हैं 0.1 बार, ऐसी सोच रहे थे आप भी, करेक्ट है?
Yes.
ठीक है। नाउ अब 0.5 बार से कहाँ जाना था हमको? 2 बार। अब
Hmm.
0.1 बार से कहाँ जाना पड़ेगा? 2 बार, इन ऑर्डर टू स्टॉप ऑस्मोसिस, करेक्ट है?
Yes.
That is why we can say that osmotic pressure को pi से डिनोट करते हैं, pi of 2 molar solution will be greater than pi of 1 molar solution। बिकॉज
Hmm.
0.1 से 2 जाने के लिए आपको 1.9 बार लगाना पड़ेगा, और यहाँ पे आपको सिर्फ 1.5 बार लगाना है। ठीक है। दैट इज वी कैन
Hmm.
से दैट प्रेशर, ऑस्मोटिक प्रेशर डायरेक्टली proportional to the concentration, and then
Concentration.
and because vapor pressure is going to depend also on temperature, because